All right, here's your first example using the double angle formulas. So they're all listed right here. Remember, we just had one formula for the double angle for sine, but we came up with three using that Pythagorean identity. All right, so example 1 says cosine of theta is negative 2/5, and they tell us that theta is between pi and 3 pi over 2. So remember, we have, this is 0, this is pi over 2, pi, 3 pi over 2. So if it's between pi and 3 pi over 2, we know we have to be in the third quadrant. Now, in the previous section, in 6.5, in Wendy's videos, she shows you how to solve for these using that Pythagorean identity, which is so great. It depends on what kind of brain you have, I believe. So I'm a visual person, so I'm going to show this example, and actually all the examples on this video, using triangles. So then you can choose whichever method you like best. So if I go ahead and I place my triangle where it needs to be based on where theta lives, we know it's in the third quadrant. They tell us our cosine is negative 2/5. So remember, that's adjacent over hypotenuse. Our hypotenuse can never be negative due to the Pythagorean theorem. So this has to be negative 2. And then I can find my y movement, you can call it x, whatever you like to do, by doing Pythagorean theorem. So I have negative 2 squared plus y squared equals 5 squared. So I get positive 4. I guess I can figure that out. That's a 25. Y squared equals 21. So my y is root 21. That's 7 times 3. I can't simplify it anymore, so it just stays root 21. So then we know this is root 21. You pay attention to which quadrant you're in. So since it's in the third quadrant, it has to be a negative. And now it's just a matter of plugging and chugging. So I'm just going to rewrite the formula because it's hiding from me up there. So 2 cosine of theta, and our theta is defined by this triangle. So cosine of theta of that is, oh, forgive me, I switched it, but hopefully you're okay with that, but I'll go ahead and write it exactly how it should look. But remember, multiplication, it does not matter order, so I'll just rewrite it though. Sine theta, cosine theta. So sine of theta is going to be negative root 21 over 5, because it's opposite over hypotenuse. Cosine of theta, that was given to us, so hopefully none of us butcher that. And I go ahead and multiply. This is over 1. I got a negative times a negative, so we're at a positive 4 root 21. 1 times 5 is 25. Now, I really want to encourage you, if you do use this method, to show me your triangle, because if you have like a simple arithmetic error, I can see this and then I can grade your answers based off your triangle, because you shouldn't get everything wrong just because, whatever, we made a silly mistake. So this should be a good old B, not an A. So for the second one, it just depends on which one you want to use, because again, we have 3 to choose from. There is some strategy here. Because cosine was given to us, I might want to use the one that only involves cosine, just in case I butchered this triangle. But it does not matter which one you use. You should get the right answer. Right and same answer. So I'm going to do 2 cosine squared minus 1. Well, I know my cosine is negative 2/5. I need to square that. I'm going to put this over 1. I have this 2 over 1. So when I square that, I get a positive 4 over 25, and I'm going to take away a 1. Following good old PEMDAS, order of operations, I multiply first, so I get 8 over 25. Well, I have to take away that 1, but we need a common denominator. So that's going to make this 25 over 25. And so 8 take away 25 is a negative 17 over 25. So this is my double angle for cosine based off this triangle. Okay, see you next time.